Hey, everybody. Well, okay, so today we're going to be talking about coastal habitats. But first, I just want to remind you of my office hours, of which I have different hours on Tuesdays and Thursdays to try and accommodate different people in different classes. But I'm also available to meet with you via Zoom, on campus, sometimes before and after class, and can make arrangements to meet you a little later if need be. So do please reach out to me if you need any help. I don't want anything in this class to be causing you anxiety or stress. And a lot of times that's just based on not really fully understanding what it is that you're being expected to do, and or struggling with a couple of detail issues that are relatively small in the big picture. So if that's the case, if you're feeling like you're beating your head against the wall or something, you're frustrated or whatever, definitely reach out to me because that's not where I want you. So once you're in this big part of your frontal brain here, that's where all the good thinking happens. This little part back here, the medulla oblongata, that's only good for fight or flight. No good higher thinking happens there. So let's stay out of that part. Okay. All right. So let's see here. Can I move the slide? Yes, I think I can. Yeah, look at me. Okay, so as I said, we're going to be talking about the coastal environment today. It's kind of an overview. This is a two-part lecture series, and so let's move forward. Okay. All right, so let's start out by talking about our estuary, Galveston Bay. So the bay is really unique in part because of the nature of the Texas coast as a whole. So, looking at the satellite imagery, let me get my laser pointer here. Sorry, I don't ever think to do that before I get started. So, I'm sure that will be a theme moving forward. So, when you look at the entire Gulf Coast, the northwestern part of the Gulf Coast, extending from Louisiana all the way down into Texas, the coast is largely shaped by sediments. Now, there have been a lot of geologic activities that have occurred over the last several 100,000 years. Just about 60,000 years ago, the coastline of Texas would have been up here in the central part of the hill country. In fact, you can see this ridge where my laser pointer is. That really describes where that coastline would have been at that time. Much of this lower part of the coast here is shaped by there was an uplift that occurred there. So this was underwater, as I said. There are sediments from that. There are sediment deposits from the rivers, which have had an outsized influence on the nature of the geology of the coast. And you can see that when you look at this image. You can see the rivers, you can see the scars, the meander scars that they have created here, and you can see the embayments. And these embayments are shaped in part by all of this activity here, but also by things going on in the Gulf proper. Now, particularly sediment regimes, and actually, if you look at this image, you can see the pattern of sediments that are in the water, all the way emanating all the way from the Mississippi River, which does again have an influence on what kind of sediments are present and how that actually shapes things like barrier islands, for instance, we're going to talk about as the semester unwinds. Okay. Anything else I want to tell you on this slide? I don't think so. Okay. Okay, so when you look at the Texas coast, you can see here that there are a number of different bays. So looking at Texas coast, all these coastal counties, right? And then there are a number of bays that stretch all the way down the coast from Sabine Lake through Galveston Bay, which is the largest of the estuarine systems along the Texas coast. Most biologically productive as well. We're going to unpack that more as we move forward. All the way down to the Laguna Madre. There are some similarities and some differences between these different estuarine systems, but in general, the freshwater inflows tend to become less as you move down the coast, north to south, and the salinity tends to be higher. Generally, these are considered to be primarily major estuarine systems, so they're relatively large, with a few exceptions. So if you look at like Christmas Bay, and we're going to talk more about Christmas Bay over the semester, this is really important in terms of conservation and seagrasses and things that we're going to discuss. But other these smaller estuarine systems, the Rio Grande, believe it or not, does or did have an estuarine system. The Rio Grande, the water management in the river, combined with decreasing amounts of water entering the river naturally, between agricultural uses, some municipal uses, the river really doesn't flow out to the Gulf of Mexico at some points of almost every year. And so it's actually salt water penetrates up into the river some distance. So that system is really highly altered. But here again, by and large, these are major estuarine systems. As I mentioned, the Texas coast has changed a lot, and this is very shaped by this. Well, there were uplifts that occurred, and you can see there were a handful of them. But also, this would have been underwater, and so it's very influenced by sediments that were deposited during that time, along with sediments that have been deposited over these thousands of years by these rivers. So again, really shaped the nature of the coast and how these estuaries function, and continues to do so today. All right, so I've used this word estuary several times. What is an estuary? Well, it comes from the Latin estus, or tide, and estuaries are semi-enclosed bodies of water where you have both fresh and salt water mixing, fresh water typically emanating from rivers or creeks, streams, that kind of thing, mixing with water from the ocean. Um, Inflows, right? So inflows are referred to as those river flows, okay, or stream flows. These bring not only fresh water, but nutrients, sediments, organic material that's important to the geology of the bay, but also to the biology of the bay. In the input from whatever the ocean body is or sea is brings in salt water. A lot of plants and animals arrive as larvae from the ocean. There are a lot of animals also, pelagic animals, that spend part of their time in the ocean. So in this case, the Gulf of Mexico, and part of their time in the bay. A lot of that's around utilizing bay resources for reproduction and young. Um, and there's also a lot of interaction between the wind, freshwater input, tides. So you've got all of these different things happening daily, seasonally, or annually that affect the salinity of the bay, among other factors. Typically, estuaries have brackish water. So brackish is really a pretty broad term, and it's um, I hate to say that it's misused often, but it's not a very precise word because of the range, as you can see, anywhere from almost 0 to 30%, which is almost ocean water. So essentially, if it's less than ocean water, but not 100% fresh, it could be considered brackish. Um, and so I'm going to unpack that a little more as we move forward, because there are some specific breakpoints in salinity that have real significant observable effects on the types of biologic organisms you'll find in different areas. So essentially, you have a positive estuary where you have more freshwater input than freshwater loss, right? A negative estuary is where you have more freshwater loss and you have freshwater input. Well, what do we mean by loss? Well, loss is where you have flow that is moving out into whatever its receiving body is. And so in Galveston Bay, for instance, as you're going to see, the bay is a positively influenced estuary. So we've got two major river systems, the largest of which is the Trinity River that extends clear up into the Dallas-Fort Worth area, if you know where Denton County is, where UNT is located. It, that river flows all the way from that area. So things that are happening up in far north Texas have an influence on our bay system down here near Galveston. The other is the San Jacinto River. The San Jacinto River is considerably smaller than the Trinity River, and its influence is a little bit lesser. There are some other factors, though. We're going to talk about the influence of the Houston Ship Channel. But the other thing is that there are a number of other smaller systems that feed into this. And I didn't even draw them all. There's some over here on the east side as well. So where I have arrows like this, these are things like Clear Creek, which again has a significant influence on this part of the bay. Dickinson Bayou, Highland Bayou, down here, Chocolate Bayou. Over here, there's Double Bayou. There's a lot of sheet flow that occurs, especially over here in Chambers County, out of the Anahuac National Wildlife Refuge. Texas Parks has properties over there. The Galveston Foundation has these properties over there. It's largely open, undeveloped land. And so there's a lot of marshes and other opportunities for water to move off of that land, the sheet flow into the bay itself. So this area, we receive upwards of 47 inches of rain a year. So it's quite wet here. And so that combined with the topography really allows, and the geology that underlies that topography, really allows for a lot of fresh water into the bay. So it is definitely a positive positive inflows system. You could compare that to the Laguna Madre, for instance, which has very little freshwater inflow, and most of the water that gets in there is from the Gulf, and it gets trapped during low tides, and because of evaporation, it actually is super salty, right? Saltier than the Gulf in many instances. So in that case, that would be a negative estuary there. So, or negative freshwater input, so you have a higher loss. All right, so when we talk about geomorphology across, so there's, again, 7 of these estuarine systems across the Gulf of Mexico, 8 if you count the, well, I put 5 there. Ignore that. So there are 7 major and 4 minor. Oh, I know, I put 5. There would be a 5th minor. Don't ignore that. So there would be a 5th minor bay or estuary system there. And so that's along more than 350 miles of the Texas coast. Texas estuaries are all bar-built estuaries. So if you look at this map right here, you can see that off of the primary coastline, there's a secondary line of these islands. Galveston Island and Bolivar Peninsula are a part of that series, right? And so these lagoons and bays are protected from the Gulf of Mexico by those barrier islands, sometimes which are no more than kind of glorified sandbars or sand spits, but they are protected by that, and that limits the tidal input, right? So they're not just part of the Gulf of Mexico, they become their own distinct system. Now, when you look at the Gulf as a whole, there are circulation patterns in the Gulf that affect sediment budgets that actually help develop these barrier islands in combination with sediment outflows from the rivers. We're going to talk about that a little more, especially when we start talking about dunes a little bit, a couple weeks down the road. But in general, water inflows from the Caribbean between Cuba and Mexico and works its way up here, and then it kind of bifurcates when it gets up here near Louisiana. Part of that bifurcation occurs because of outflows from the Mississippi River. Now, the Mississippi flows a lot of water. It has a huge watersheds or drainage basin that encompasses almost 1/3 of the entire United States. So it is a lot of water coming down that river, exiting out into the Gulf of Mexico. And that's part of why the state of Louisiana is shaped the way it is because of all of the sediments accreting there in this kind of delta type estuary that forms there. In any event, that water flow out has an impact to a degree on inflows from the Caribbean Ocean into the Gulf of Mexico. So it bifurcates, and part of that water kind of slips over here towards Florida and then out towards the Atlantic. Part of it slips over here along the southern Louisiana and upper Texas coast, and it works its way all the way down almost to Corpus Christi. But notice there's another flow here that actually kind of makes this turn around the Yucatan Peninsula here in Mexico and flows along here, and it's flowing upward. And so they all kind of meet in this area. And if you've ever driven down the Texas coast or spent time down in South Texas, you'll notice that the beaches. So, for instance, if you go to Corpus or especially to Aransas, the sand is different. It's whiter, and that's because there's more influence from different sediment sources that have less clay and other organic material in it than these sands down here. It's the same reason why Florida's beaches over here tend to be whiter and nicer is because they're more affected by coral. And so you have more coral sands than you would over here in the upper Texas coast, lower Louisiana, which is much more influenced by the sediments that are coming out of our rivers, including the Mississippi River. There are also wind currents that affect how this sediment piles up along the coast. And then these outflows, how much water is flowing, can determine what kind of estuarine system you have. Now, I noted to you that our estuaries along the Texas coast are all or barrier island type estuaries where you typically have these tidal inlets and some freshwater inflow. So you get that mixing of salt and fresh water in this estuarine system, which kind of makes it unique. It's unique from the river that's feeding it on one end and unique from the Gulf of Mexico that's feeding it on the other, right? Now, that doesn't mean they're all equal because the amount of salt, the amount of salt water and the amount of fresh water that are feeding into those varies depending where you are on the coast. Remember, I told you it tends to get saltier as you move your way from the upper coast to the southern coast. And that's because there's less freshwater inflows relative to the amount of salt water that flows in there. So when you look at some of these, like the Laguna Madre, parts of the Laguna Madre are true lagoons where they don't have much in the way of fresh water, so more like C and D in this diagram down here. They don't have much in the way of fresh water flowing in. And so salt water that gets in there tends to just hang out. And high amounts of evaporation can actually allow salinities in these lagoons to be higher than the salt water that's feeding them from the Gulf of Mexico at certain times. So again, there's uniqueness to each individual bay, and a lot of that is shaped by the geology of the coastal system itself. I also want to point out that our estuaries here, right? So you're looking at the backside of Galveston Island here. Our estuaries are different than estuaries that you might see in other parts of even the United States. So if you spend any time on the West Coast, and I'll use Puget Sound as a great example of a fjord type estuary. A lot of the estuaries over in Northern Europe are this type of estuary where they're actually formed by glacial retreat. So when glaciers pushed out, they created these deep caverns, not caverns, chasms. Sorry. They created these deep chasms, right? And so they tend to have very steep walls and they tend to have very deep waters and very different if you think about how flat and open and shallow, Galveston Bay is, for instance. We'll unpack that a little more later as well. So these tend to be very different. And so in terms of their bathymetry, it's different, but also in terms of how water is partitions along the water column from the top of the water, surface of the water, all the way down to the estuary floor. So if you look at this guy, let me see if I can get my back here. So If you look at this guy, you can see typically what you see is salt water moving in from whatever its receiving body is. So usually an ocean of some sort. Puget Sound, it would be the Pacific. So you've got salt water pushing in, and salt water has a higher density, so it's typically is lower. And then you've got fresh water that's pushing out from snowpack melt, rivers, that kind of stuff. And because of the depth, you actually get a freshwater lens. It's referred to as a freshwater lens that occurs on the surface. You see this in groundwater sources as well, in aquifers. But in this case, in these fjord type estuaries, the freshwater is really kind of its own system, and they flow in opposite directions. So the salt water is flowing in while the fresh water is flowing out, and you don't get a lot of mixing in those things. Whereas in our estuaries here along the Texas coast, they're shallow, and there's a lot of mixing that occurs. So there can be a slight gradient, but the gradient isn't substantive. Like you're not going to go from 0 to 35 parts per thousand as you drop your salinity meter through 6 feet of water. You're not going to see that. Now, again, we're going to talk about the nature of the Houston Ship Channel because there are some differences there because of the depth. We'll follow up with that. Tides. Let's talk about tides. So tides, there are basic types of tides. So there's diurnal, semi-diurnal, and mixed semi-diurnal. And really, this is about how often that time those tides occur. So if you have high and low water once, repeated every day, then you've got a basic diurnal tide. If you have high and low water repeated 2 times a day, then you have what's referred to as a semi-diurnal tide. And you can see this difference in these graphics, right? Then you can have a mixed semi-diurnal tide, and that occurs when you have high and low water repeated twice a day, like the semi-diurnal tide, but it's mixed because of the different heights of the tides that occur. Okay, so these tides result from these gravitational forces, right, and centrifugal forces associated with the Earth, the Sun, and the Moon. All right. So, and the problem here is, or the reason, I shouldn't say it's a problem, but the reason tides occur is because water is a fluid, like the air above it. Okay. And so it doesn't behave the same way that the Earth's crust does. So that water bulges as it deals with all of these different forces. So partly you have gravitational force exhibited by the Earth itself, holding the water to the surface. You've got the moon, which has its own gravitational force pulling on the water as it orbits the Earth. And then you've also got the sun. We'll factor that in here in a minute. But as the Earth spins, not only is it creating gravitational pull, but it is also creating centrifugal forces, right? So there used to be this great ride in an amusement park that I used to go to when I was young in the Kansas City area. Some of you may remember Astroworld, many of you may not. Was one that was here in Houston, but in any event, the one in Kansas City, Worlds of Fun, was what it was called because it was Worlds of Fun. In any event, they had this ride you get in, and it was like a cylinder, right? And you get inside the cylinder, and they spin the cylinder, and it would force you up against the wall, and then they drop the floor out beneath you, and you'd be stuck to the wall, right? And so it's got this force that's pushing you out towards the walls. Okay, so that's kind of what happens with the water here. It's being forced out in a way as that Earth, as the Earth is rotating around its axis. So when these two things interact, you actually end up with kind of two different bulges, okay? These two different things happening. Plus, you've got the force of the sun, okay, which is keeping us where we are and preventing us from flying out to space. So you've got the Earth's gravitational pull preventing the moon from flying away and the water from flying away. You've got the moon, which has its own attractive force, and then the sun. Okay, so in other words, the water is being affected by all of these different things as the Earth spins, as the moon orbits the Earth, and as the Earth orbits the sun with the moon. Right? So you end up with these different tides. And so we'll start with a spring tide. We're going to start with one of these. So a spring tide is the result of the alignment of the Earth, Sun, and Moon during a full or a new moon. Okay, so a full moon occurs when the moon is on the opposite side of the Earth from the Sun. Okay, and that's why you can see it because its lit surface is towards the Earth. The new moon is when you don't see the moon, right? And that's because the lit surface is away from the surface of the Earth. So, what ends up happening here is you get so during a new moon, you got the force of the sun, the gravitational force of the sun, the gravitational force of the moon, and this centrifugal force occurring, and you get this really high tide. Okay. Then, when you got the new moon, you've also got a relatively high tide. The Then on the first and last quarter moons, you'll notice that the moon is at a 90-degree angle from the sun. And so it's pulling the water kind of counter to what the sun is trying to do. And that then in turn leads to these smaller tides referred to as neap tides. Now, I'm going to direct you. There's a really good animation down here. So I've got a link down here. I would encourage you to look at this short video. It's only about 5 minutes, and it does a really good job with this, better than I could do in a slide presentation by far. So I would encourage you to take a look. All right, so when we look at tides in Galveston Bay, you have both gravitational and centrifugal forces that are disrupted by the Earth's rotation, remember, and also the coastlines. Because if you think about it, the geology here is unique. This is not just a big circle. It's got all of these undulations and cuts and these bays, all this stuff going on along the edge of the continents. And those create drag, they create chain, they affect essentially the way the water is flowing. There are also bathymetric differences that occur on the seafloor. So if you think about bathymetry, it's the same as topography, except it's occurring underwater, right? So that bathymetry changes, and that interrupts those gravitational tides even further, along with density gradients. So again, the more salt you have dissolved in the water, the denser the water is. That has so the heavier it is, that makes it behave. The density affects how that water flows as well. So you end up with these really unusual tidal cycles that are different depending on where you're located in the Gulf of Mexico. All right, so our tidal range in Galveston Bay is relatively low, typically about 42 centimeters. So, we're not talking about, we're not talking about big changes here. And so we have 14-day cycles of diurnal and semi-diurnal tides. And there are also some unpredictable tidal changes that occur in Galveston Bay because of wind. And that's because the water is very, very shallow, right? And we're going to talk about that, but the average depth of the bay is only about 8 feet. So, and in most areas, it's shallower than that. So that can have an impact. So you can see how you have, our diurnal tides here. Again, this looks like a lot. But look at the scale here on the x-axis, and you can see that these are very small differences, right? So the difference between high tide and low tide, if it's a foot, that's quite a bit for us. And then you also have these semi-diurnal tides that occur where you get what looks like a normal tide, and then when it recedes, you get a slightly different tide than the one before it in these spaces between these primary tides. So it's a complex system, and you can find data on tides, by the way, if you go to this website that's operated through NOAA, you can see what the tides are going to do and track it, actually. Okay, So I mentioned wind because wind can have an influence on these tides. And that's because the winds cause these setches, and these setches are temporary oscillations that occur in water, kind of creating a standing wave. So it kind of pushes the water up one direction, and that water just kind of sits there, right? And so you see this. I think this is most noticeable in our area when we have strong winter cold fronts that come through and they push all the water out of the bay. So if you come up to the north part of the bay where my campus is, you'll see Goose Creek and Cedar Bayou and Clear Creek are all really low. Like you can see a lot of sediment along before you get up to the bank and the water's really low in it. On the other hand, during the summer, when we have really strong southeast winds off of the Gulf of Mexico, you'll see really high water levels in the bay and in its tributaries. So along West Bay, for instance, you see the water way up on the shoreline. And that's essentially what's happening here. And that can actually kind of override the normal lunar tides. And this is very different and unpredictable than the scales of our normal tides because those are affected by normal gravitational forces, right? That are predictable. In this case, this is far less predictable. And again, it's outsized in shallow bays like here in Galveston Bay. Okay, um, give you a sense of what you would see in terms of how wind might affect a tide relative to the predicted tide. So this is data from 2006. And so what you're looking at here are the predicted tide levels, okay, in blue. And here again, you can see that mixed semi-diurnal tide that they predict in here, right? So some larger, some smaller, not even, okay? And so over this cycle, you can see that the verified tide, the measured tide, really took a steep deviation away from what was predicted. Even though this tide was predicted to be a little bit lower, I mean, here again, look at what the scale is. We're not talking about huge differences, but this was, predicted to be modestly different than the one before it. What actually transpired was a substantial difference for a while, and then it went back to the predicted level. Now, before that, it was just a little bit higher than what was predicted. And that has to do with the winds, right? So the winds, if you look down here, at this point, you've got the little blue arrows here are the steady winds, okay, and the red line are gusts, right? So here we've got steady winds that are east southeast, meaning that's the direction they're blowing from, okay. So that would mean if you were standing on the beach on Galveston and looking out towards the Gulf of Mexico, the wind would be hitting you in the face, essentially, right? So it's pushing water in from the Gulf of Mexico through Bolivar Roads and up into Galveston Bay, all the way up to where I'm at up in Baytown, right? You just keep pushing that water up there. And so these were pretty steady winds, right? It's not like they were kind of hovering right around 10 knots, right? So that's all fine and good. And you can see that, sure enough, it made the tides a little higher than you would expect. They kind of behaved the way the underlying lunar tides would have behaved. So, and that's partly because these weren't gusty winds, they were pretty steady winds, right? So it was just making the water depth deeper overall. The baseline water depth was deeper than it would have been. And so the tide was slightly higher than it would have been, but it still behaved like a lunar tide. Okay, until a cold front came through. And when that cold front came through, you know how cold fronts, when you get those winter fronts, they get that really cold, sharp, strong wind that blows through at the start of the front. And so you can see here that the wind was very gusty here on December 1st, but you can also see the shift in direction. So now we've got winds that are coming out of the north, northwest, and west. That means it's pushing water from where I'm at up in Baytown down to you in Galveston and out into the Gulf of Mexico. And so the water level went down fairly substantially here. And in this case, it went down nearly 2 feet, if I'm reading that right. Yeah. And that's because of that very strong wind. And it really just pushed it out and it kind of overwhelmed the lunar tides. Like you don't even much see the influence of the lunar tides here, hardly at all, until the front had passed and then the wind started to return. And kind of, again, the winds weren't as strong, but also they weren't gusty, right? And so those winds kind of returned from the east southeast and then those tides kind of went back to normal. And in fact, here, these winds are, gosh, they're almost right out due north. And so that would have, because of the arrangement of how the bay is arranged on the Texas coast, wind coming down from the north is just going to kind of push water from Anahuac over to Clear Lake. But if it's not a very strong wind and it's steady, you may not even notice it a whole lot, right? And so here, again, you can see that this tide is pretty much what was predicted, that lunar tide. So, you can also see this in air temperatures. So there's a station over at Eagle Point, which is kind of in the San Leon area. If you're familiar with that area, it's a little south of Kima. And so you can see here, right when that front blew through, the temperature dropped as well, and that usually corresponds with those winds. So you can find current conditions. This is from last year, but you can get on and find those current conditions. Go to that website, explore it a little bit. This is actually really good data. And for you guys that are going on in the fields related to marine biology, marine sciences, understanding tides, winds, all of these weather patterns that have such an outsized impact on our uh, lacking a better word on the biologic community that's present. That it's worth your time to spend exploring this and familiarizing yourself with it. And in the notes, when I put the notes up on Canvas, I'll include a website that you can go to again. Okay. All right. So your clicker questions here. So you have a storm coming through with southerly winds. Um, this storm will typically cause observed tides in Galveston Bay to be higher than predicted, lower than predicted, about the same as predicted, or semi-diurnal. Well, if you answered A, so remember east, southeast. So if it's generally southerly, it's going to be a little higher than predicted because again, remember the coast is kind of like this. So this is directly east. So if it's coming out of the south, it's pushing water. So if it's coming out of the south like this, it's pushing water into the bay. If it's coming east, southeast, that's almost a direct pushing there, right? So a southerly wind would result in a higher than predicted. And a bay with diurnal tides has one high tide and one low tide per day, okay? Which isn't typical for us in Galveston Bay. Okay, well, again, remind you of my student office hours, and we're going to pick up here when we come back next time.